Okay, so today we are starting our rational functions unit. The first lesson in this unit is over variation. And the reason that this is included as the first lesson in the unit is that one of the variations, inverse variation, is modeled by the graph of a rational function. Okay, so that's why it's kind of stuck in here. Starting tomorrow, we will really dive into rational functions. So a lot of this is review. Some of it's a little new. But we're going to talk about different kinds of variation. So the first kind of variation we're going to talk about is direct variation. Direct variation is given by the equation y equals kx. Okay. K, and I will go ahead and let you know that sometimes I write my k's like a cursive lowercase k, which can be misconstrued as an R. But just be aware that's how my k's come out sometimes. I try and remember to write them not like that when I'm teaching, but I forget. So that's a k. K is for all the variations, not just for direct. That's why I'm writing it outside the box. K is the constant of variation. Okay, K is the constant of variation. And it's important to note that K cannot equal 0. If K were to equal 0, we wouldn't have a variation any longer. We would just have a horizontal line at y equals 0. So in direct variation, we have y equals kx. What type of graph would this end up being? Yeah, so direct variation is always a linear function. What do you know about the y-intercept of this graph? It's 0. There's no plus b at the end, so your y-intercept of a direct variation will always be the origin. Direct variation will always go through the origin. The way you'll see this in a problem, or the way you read this, is y varies directly as x. All right, so look at 1. We're told y varies directly as x, so that means we're going to use the equation y equals kx. And then we're given a set of values. We're told y is 8 when x is 20. So what that allows us to do is solve for k, find our constant of variation, and then write our direct variation equation. So to find our constant of variation, we're going to plug in 8 and 20. So we have that 8 equals k times 20. We would divide both sides by 20, so we would get 8 over 20 equals k. So what would k reduce to? 2/5. Okay, so that's one thing I'm checking for is the constant of variation. The next thing I'm looking for is that you've plugged in the constant of variation and written your direct variation equation. So this gives us y equals 2/5 x. All right, so that means our constant acts as what in our equation? Yeah, it's essentially the slope. Let's go ahead and plot this direct variation on this graph. So we know it goes through 0, 0. And then what's the slope? Good, 2/5, so we go up 2 over 5. All right, use your graph to kind of fill out your table. All right, looking at your table, this is going to help us in a little bit. For now, just looking at your table, as x increases, as your x value goes up, what is your y value doing? It increases as well. So indirect variation, as x increases, y increases. All right, I want you to go ahead and look at number 2. I want you to find your constant of variation and then write your direct variation equation. When you think you've got your equation, check in with someone next to you. Okay, what's our k value? K is 8. And what's our direct variation equation? Good. Questions on that? Alrighty. So in an application problem, you would just take what you're given and basically translate it into your equation. So it says the cost of an item in euros, E, varies directly. So I'm going to have E equals, as soon as I see that word varies, I'm going to write down my constant K, and directly as the cost of the item D. So it was Y equals KX, so this is E equals KD. With directly, you put your variable right next to your constant. All right, we're told that 3.85 euros is when we have $5. So plug those in. I have 3.85 equals K times 5 for my D. So what would I do? Divide by 5. And 385 divided by 5, what does that give us? All right, so that's our K value, which now we can rewrite our equation. How do we rewrite our equation? Good. All right, go ahead and use that equation to find D when E is 10 euros. How would we do that? Okay, so we're going to plug in 10 for E. So we have 10 equals 0.77 D. And then what would we do? Divide by 0.77 and we get 12.99. And what are our units? Dollars. So on your homework, on a quiz, anywhere, I'm going to be looking for this equation, E equals 0.77D, and I'm going to be looking for your final answer. So make sure you write that out. Okay, a special version of direct variation is called joint variation. All right, and joint variation is given by the equation y equals k times x times z. So joint variation basically means y varies directly with x and with z. So you could write yourself a little note that this basically, that word joint should give you the indicator of direct. So y varies directly with x and with z. You see the word joint, you should think direct. You'll see y varies jointly as x and z. Okay? So look at 4. The volume V of a cone varies. So as soon as you see that, you're going to stop and write V equals K. Varies jointly. That word jointly signifies what to you? Direct. So varies directly as the area of the base B and the height H. So V equals 12 pi when B equals 9 pi and H equals 4. All right, well, what's 9 pi times 4? 36 pi. So we have 12 pi equals K times 36 pi. So what should I do? Okay, divide both sides by 36 pi. What is 12 pi over 36 pi? 1/3. All right, so we get that 1/3 is K. All right, so what's our joint variation equation?
B equals 1/3 BH.
Good. All right, and we're given that the volume is 24 pi. And the height is 9. We want to solve for B. What's 1/3 times 9? 3. So we have 24 pi equals 3B. So what would we do? Divide by 3, and what would we get? Yeah, so the area of my base B is 8 pi, and what are my units? Feet squared. What does B represent? Area. Questions on that? All right, so let's talk about inverse variation. All right, inverse variation is represented by the equation y equals k over x. Okay, so notice, where is your x this time? In the denominator. So with varies directly, you put your variable in the numerator. With varies inversely, the x goes in the denominator. Okay, so what must be true about x based on this equation?
It has to be smaller than 1.
Can't be 0. Why? Yeah, it's in the denominator and we can't divide by 0. So it's important to know in an inverse relationship, in an inverse variation, x cannot equal 0. All right, so y varies inversely as x. All right, now just by looking at this equation, y equals k over x, that's not one of our parent functions we recognize. In fact, is the parent function of our upcoming unit, rational functions. This is a transformation of y equals 1 over x, which is our rational parent function. Okay? So let's work number 5, and we can get an idea of what this graph looks like. So we're told y varies inversely as x. So how do I write that equation? Y equals k over x. And y is 4 when x is 5. So what does that tell us? K is 20. So what's that inverse variation equation we can write? Good. And you'll see sometimes instead of the word inverse, you might see indirect. Means the same thing. All right, let's fill out this table. If I plug in negative 10 for x, what do I get for y? Okay, what if I plug in negative 5? What if I plug in negative 4? Negative 2? And negative 1? Negative 20. Why are we skipping x equals 0? Yeah, x can't equal 0, so your function is not defined at x equals 0. So when we plug in 1, what do we get? When we plug in 2, 4, 5, and let's replace this 8 with 10. So 2. All right, so let's plot these points, and I'll show you how to connect the curves. So I'm not going to plot the 120 or the negative 1, negative 20, because that's going to go far off my graph. All right, so here's how we graph this. This graph has 2 pieces. Okay, and this shape is the shape of the rational parent function. Now we know that x cannot equal 0, so what are we never going to cross?
The y-axis.
The y-axis, because I can never have x equal to 0. So I also know that k can't equal 0. So will y ever equal 0? No, so we never cross the x-axis either. All right, look at your table. As x increases, what's your y values doing? Decreasing. So in an inverse variation, as your x value increases, your y value decreases.
So is the domain and range for this going to be everything except for x equals 0 and y equals 0?
All right, would you please try number 6? Think about your fraction rules. Try number 6. All right, how should I start this off? What would I write? Y equals k over x. Then how would I plug in my point, or my numbers? Okay, dividing by 1/3 is multiplying by 3. So k divided by 1/3 is the same as k times 3. So what is k? K is 9. All right, and so what would our equation be?
Y equals 9.
Good. All right. The time that it takes for a group of volunteers to construct a house varies. So I stop right there with that word varies, and I write T equals K. As soon as it says inversely, what does that tell me? Yeah, we're going to put our variable under K. Varies inversely as the number of volunteers, V. So my equation is T equals K over V. Okay, 20 volunteers can build a house in 62.5 hours. So if I plug those in, what do I have? Good. How do I solve that? Okay, and if I multiply by 20, 1,250 is my K value. How does that help me? Okay, now I rewrite my equation. So, sorry, that should say 1,250 equals K. So my equation is T equals 1,250 over V. Remember, I'm looking for that equation. Okay? So where do I plug in 50? For T. So 50 equals 1,250 over V. Multiply by V, so I get 50V equals 1,250. Good, divide by 50. So what do I get? 25 what? Volunteers. Questions? John, not get the stapler yet? Where's the stapler, guys? Okay. So, we are given a table, and we want to decide direct variation, inverse variation, or neither. So the way you're going to at least start this is look at your table and figure out what X and Y are doing. So in table A, as X increases, what does Y do? Decreases. So which of those could that be? Direct or inverse? Inverse. So my goal is to see, okay, is this inverse variation or not? How do you think I could test that? Plug it into what? Your equation. What's our inverse equation? Okay, and what are we looking for? Yeah, we're looking for our K. And for this to be an inverse variation, what would have to be true about K? It can't be 0, and it has to be the same for each set of points. So start with that point 6.5, comma 8. So 8 is my Y value, so I want to know 8 equals K over 6.5. Multiply by 6.5. What's 8 times 6.5? So K is 52. Okay? Now we're going to check our next point. 4 equals K over 13. What's K? 52. All right, so far so good. Check your last point. 0.5 equals K over 104. What does that give us? 52. So since your K values were the same, this is an inverse variation with K equal to 52. All right, look at B. As your X values go up, what do your Y values do? Go up. So what are you checking? Direct. All right, go ahead and work B and C. All right. So on B, when you tested direct, did it work?
Yes.
Yes. And what was your K value? All right. On C, what did you check? Direct. Did it work? No. Why not? Good. K was not constant. Okay. Last kind of variation we're going to talk about today is called combined variation. Okay, and what combined variation means, as you might guess, is that y is going to vary both directly and inversely with two different variables. Okay, so combined variation includes both direct and inverse variation. Direct variation tells us to put our variable in the denominator with k or in the numerator, or sorry, in the denominator under k or in the numerator next to k? In the numerator. So direct signifies to us that our variable goes in the numerator. What does inverse signify to us? In the denominator. So you'll see the equation y equals kx over z, where y varies directly as which variable? X, and inversely as z. Okay, do you remember when, like in Algebra 1, you were given a statement or an equation, it said a number is 3 less than 4 times whatever? You remember how you just kind of like translated that into numbers? It's the same idea here. We use keywords like varies, inverse, and direct to tell us how to translate stuff. So kind of watch how I walk through this problem. There's really very little you have to memorize, except that direct means that the variable goes in the numerator and indirect means the variable goes in the denominator. That's it. So look at this. The volume V of a gas varies. As soon as we see that word varies, we're going to stop and we're going to write V equals K. Because I know for varies, I have to have a constant of variation, K. All right? The next keyword I see says inversely as the pressure P. So with inversely, where are we going to put that variable? Yeah, under the K. All right? And then it says directly as the temperature T. So where am I going to put T? In the numerator. That's all you have to do to write these equations. Don't make it harder than it is. Simple. It's supposed to be simple. Okay? All right. A certain gas has a volume of 10 liters, a temperature of 300 Kelvin, and a pressure of 1.5 atmospheres. So let's solve for K. What would we do? Okay, multiply by 1.5. 10 times 1.5 is 15. Shame on you if you went to your calculator for that. Just saying. 15 equals 300K. So we divide by 300. So think about this. 15 goes into 30 twice, so 15 goes into 300, 20, so 1/20th is equal to K. Now, when you go to write this in your equation, what you think to write is V equals 1/20th T over P. But that's not very proper math grammar. We don't really like having a fraction in the numerator. So what could we do?
Put 20 on the denominator.
Yeah, put 20 in the denominator. So really, the way you want to write this is V equals T over 20P. That's the equation I'm going to want from you. All right? So it says, if the gas is compressed to a volume of 7.5 liters and is heated to 350 Kelvin, what will be the new pressure? So plug in your 7.5. We know 350 Kelvin over 20P. What would we do first? Multiply by 20P. 7.5 times 2, what's that?
15.
15, so what's 7.5 times 20? So 150P equals 350. Divide both sides by 150. So P equals, the zeros cancel. 35 over 15, what does that reduce to? 7 over 3, and what are our units? Yeah. Good. Questions on that one?
Does that equation
Yeah.
really work?
You can. Yeah. All right, I want you to please work on number 10. I want to see your K value, your variation equation where you plug your K value back in and then answer the question. I'm going to look for all those things. Translate it word by word to come up with your equation. All right, so what's my very original thing I should have written down? What's my original equation? P equals K N over M. Did anyone not get this? Everyone okay here? Okay. Then you plug in 5 equals K times 10 over 10,000. So one of our zeros cancel. So we have K over 1,000 equals 5. So what does K equal? 5,000. Which makes my equation P equals 5,000 N over M. Yes? All right, and then what do we plug in to, what are we asked to find? P, the price. So we have 5,000 times 200 over 100. Okay, well, 200 over 100, what does that become? 2. So what is P? 10,000. These are the type of numbers, guys, that I could give you on a non-calculator part. You need to be able to work with these types of numbers, canceling stuff out, using good technique. Okay? Okay, on your homework, write this down on your syllabus somewhere or on your notes. On your homework, numbers 17 through 19 and numbers 24 through 26, you do not need to graph. Numbers 17 through 19 and 24 through 26, you do not need to graph. Okay? All right.
Call